All right. How are you girls making out? So 7.2 and 7.3, are you finished all of that?
Yeah.
Yeah? Okay. Well, let's take a look at a little bit of 7.4. I'll introduce it today. And it won't take very long to do that. If you have no questions, I'm going to create an assignment and put it in Teams later this morning for you to hand in for Monday. We won't have class tomorrow. Tomorrow was supposed to be a day off for you, so we'll give you the day off. All right? Okay. So what we're looking at today, is parallel lines and perpendicular lines. Okay? So each one of the parallel and the perpendicular lines, they each have something in common, and they have something that is different that makes them parallel or perpendicular. So I'm going to use parallel lines to start with. So parallel lines are two lines that are parallel to each other, like railroad tracks that will never cross each other. They never intersect. So how does the equation look such that I get two lines that are moving in the exact same direction but never cross? What has to be the same? What has to be different? So is that the slope has to be the same for both lines. So that's the first thing. So the slope of the two lines will be exactly the same. All right? Because if they don't move up and right or in a horizontal, the rise of the run, if they're not the same, they're eventually going to angle and cancel each other out. Or they'll cross each other, not cancel, but cross each other. So the first thing that we need to know is that the slope, I put M here, but I'll put slope. The slopes of parallel lines are the same. When you look at this graph that I've drawn on the board here, what do you notice? Are the two y-intercepts, are they the same or are they different?
Different.
They're different. So that's what has to happen for you to have two parallel lines. So when you solve your equation, I generally use it, solve it by putting it into y equals mx plus b form. If my slopes are the same and my y-intercepts are different, I have parallel lines. All right? Okay? A perpendicular line. So one that runs this way, let's say, is create a right angle. So in this case, because I was crossing both of these, it's going to create a right angle in both of them. The slope, this is the important part. The slope between two lines that are perpendicular to each other. Their slopes will have the negative reciprocals of each other. So I'm going to write it out in words and then I'll explain it to you. The slopes have negative reciprocals of each other. All right, so what does that mean? Well, let's say the slope of and I'm making it up. Let's say that the slope of this line was 3/2. So the slope of this green line right here, 2. And because this is parallel to it, it would also be 3/2. So the slope of this one has to be the same because they're parallel, right? So what does this graph right here? The negative reciprocal of that slope. So what that means is I change the sign and I flip the fraction. minus 2 over 3. So my slopes of my two lines that are perpendicular will be the negative reciprocal of each other. All right? They'll have an intersection point that go through the same coordinate. All right? So they'll have one coordinate that's the same. Now, it doesn't necessarily have to be the y-intercept. It can be any coordinate. Okay? So do we follow that so far, girls?
Yep.
All right? Okay. So let's... It says, write an equation in slope-intercept form for the line that has a y-intercept of -4. The lines used in technology. We'll graph them without. But, okay. So there's two things that happen here. They give you the equation of one line, 5x plus 3y minus 6 equals 0. And they want you to find the equation of a new line that is parallel to that line. So I'm going to start this the same way every time. I'm going to start by going, my new line has the equation y equals mx plus b. So what are the two pieces of information I need from that equation in order to have the equation of a new line? What are the two things I have to solve for?
M and B.
That's right. Yeah, that's right. M and B. Okay, so now let's read the question again. Write an equation in slope-intercept form, so that's slope-intercept form, for the line that has a y-intercept of -4. All right, so they just gave me my first piece of information of my new equation. Y equals mx minus 4. So I get that. Now it says it is also parallel to the line 5x plus 3y minus 6 equals 0. So it's parallel to this line. So what information do I need to get from this equation to put into that equation? What am I looking for?
Slope.
Slope. And what do we know about the slopes of parallel lines?
They're the same.
They're the same. That's exactly right. So let's move everything over and let's solve for the slope of this line. So I'm going to do that by going 3y equals minus 5x plus 6. So I move the negative 5x over, or so the 5x over, and then the subtract 6 and move them over to the right. Now I'm going to divide by 3. And what is the slope of this line right here?
We're going to outside for coffee time if anybody wants to come. Coffee time outside front.
What's the slope of this new line, this line right here? So I've got it as y equals -5 over 3x plus 2. What does that make the slope of this line? Where do you find the slope?
Oh, -5 over 3.
That's right.
X.
So if that's the slope of this line, then that means it's also the slope of my new line. Like that. Okay? So the question gave us my y-intercept to start with. And then I had to find the slope of this line in order to put it in to my new equation, because the slopes are the same. Are we okay?
Yep.
All right?
Yep.
Okay. So the next, the B says write the equation in slope-intercept form for the line that has a y-intercept of -4. So the same y-intercept, but now it's perpendicular to it. So my new equation then is y equals mx subtract 4. And I need the perpendicular slope to this one on the left here. So what is, when two lines are perpendicular, what do I know about the slopes? Well, one's the negative reciprocal of the other. So I need the negative reciprocal of -5/3. What does that end up being?
-3/5.
Very close. Very close. All right. The 3/5 part is right because the sign changes. You're taking the negative of a negative, which makes it positive. So my equation of my line that is perpendicular to this one that goes through the y-intercept -4 is y equals 3/5x subtract 4. Okay?
Yep.
And then C says, write this in general form. All right? So in general form, what is the one thing that I can't have a fraction, so I need to get rid of the 5. So I have to multiply everything by 5 here. So that gives me 5y 3x minus 20. So I times this by 5, which is y, 5y. The 5 cancels here, leaves me a 3x. I should write that in. Times this by 5, this by 5, and this by 5. So I'm left with 5y equals 3x subtract 20. And then move it all to one side. And like I said before, it doesn't matter which side you move everything to, as long as they all equal 0. And that's, in a nutshell, all of 7.4 today, girls. So all you're doing is you're working with slopes and parallel lines and perpendicular lines based on what the slopes are. Okay?
Yep.
So did you have anything from 7.1 to 7.3 that you want to ask?
Could you do 1D on page 149?
You bet.
48.
148, 1D?
Yeah.
Okay, so y equals minus 0.2x plus 1.2 and write it in general form? Okay. Minus 0.2x plus 1.2. Okay. All right. So in general form, I don't want decimals, I don't want fractions, okay? So one of the things I could do is I could switch these to fractions, but it's not necessary. I have a decimal of 1/10 and 1/10 on both of those values, right? So to get rid of the decimal, I'm going to multiply everything in the equation by 10. All right? So I'm going to times this by 10, this by 10, and this by 10. And what that's going to do is that's going to then get rid of my decimal. So I'm going to have 10y minus 2x right there plus 12. Is that the step you were stuck on?
Yep.
Yeah. Okay. So you could change it to fractions. You could make that 2/10, 2/10, and then that would be 1 2/10. But it's just easier to get rid of fractions or to get rid of decimals is multiply by 10, or if it's in the hundreds, multiply by 100 and it'll get rid of it. Just as easy.
Okay.
Okay?
Yeah.
And then I would move the y to that side, so I'd get 0 equals negative 2x subtract 10y add 12.
Right.
Okay?
Yep.
All right, did you have any other questions?
Nope.
You're okay? Right on. Okay, so I'm gonna just let you girls know this. I know Avery, you're scanning just fine. So I'm going to I'm letting everybody know this. I learned this last night from one of the elementary teachers. And if you're using an iPhone or an iPad to take pictures to send the assignments in, if you use notes and you take the picture in notes, you can take multiple pictures and then send them all together in one single PDF, and then it'll print it all off at the same time. So when you're using notes, go in, use the camera thing, the picture, take a picture, and then when you transfer it, that button, when you go to transfer it or email it, okay, it will email it as a PDF automatically. So that may make things a little bit easier for everybody if we do it that way. Today, I'm going to put your assignment in Teams. So you can also, I would still prefer you do this to make it your PDF. But when you put it into Teams, you can also save it to OneDrive and then add it into the Teams that way. Okay? So this isn't necessarily for the two of you. It's more for everybody else to do. So when I get off here, I'm going to try and put an assignment together. It'll be posted probably by noon today. I'll get that assignment to you girls. Okay?
Okay.
All right. Okay, I have nothing else. We won't be on live tomorrow. Tomorrow was supposed to be a sleep-in day for you, so I'll let you have your sleep-in day because it's supposed to be parent-teachers. And that's all I got for you, all right?
Okay.
Okay, have a good weekend, girls. Talk to you later.
You too.
Okay, bye.
Bye.